Hi, my name is Jonathan Araya.
My name is Felipe Alvarado, and we're going to talk about the stellar evolution.
These stars are big balls of fire made of gas. These places are over the universe, forming galaxies. The birth of stars began in the nebulae. Those are big accumulation of gas. In this case, hydrogen and helium, and other chemical elements in the form of dust. Now, I will speak of the creation of a star. As the nebulous decrease his size by the force of gravity, this concentration of gas increase the temperature and inside to a millions of degrees. At this point, the nuclear reaction begins, where the atoms of hydrogen fuse each other, releasing energy, light, and then the hydrogen becomes in helium. From this point, the inside the star starts to increase the pressure, and when the pressure is equal to force of gravity, the main sequence of the star begins.
Okay, so now we're going to talk about the type of stars. We know that the stars are made of gas, and they use hydrogen as a fuel. In physics, we use the sun as a reference to all the stars. So when a star is like less than a solar mass, it's called low mass stars. Mostly are like brown dwarf. Brown dwarf are stars who doesn't make emission because of they don't have this nuclear reaction. It's so small in size compared to the sun, and also it's very light. One famous brown dwarf, it can be Jupiter. Jupiter is a planet and it's going to be a star like the sun. But it doesn't have this the whole mass to make ignition. So when the stars are like 1 solar mass to 10 solar mass or less than 10 solar mass, it's called mid-sized stars. And as one famous mid-sized star, it can be the sun. The stars like sun can live for a really long time, like close to 10 millions of years. Our sun it's about to 4.5 million of years and still have another 5 million of years, so it's in the middle. Our sun had in the core a temperature about 5 million of degrees, while in the outside of the sun it can be 5,000 temperature of degrees. And so when a star is about 10 times the solar mass or beyond that, it's called massive stars. Massive stars. Massive stars are mostly in blue color, or supergiant blue. These supergiant stars use the hydrogen as a fuel, but as the big size of them, they use all the hydrogen really fast. so they don't have a really long life. The color blue is because it can be related to the temperature. They are really hot. In the core, it can be above 6 million of degrees, and outside is about to 7,000 degrees.
The death of a star when the nuclear reaction is over, the pressure decrease and the force of gravity wins, making the star to collapse into itself. In the core of the star, the hydrogen becomes in helium, and the helium becomes in heavy elements like carbon. In the outside, when the star collapses, release are the elements to the universe to form another star.
Okay, so now we're going to talk about the destiny of a star. When a normal-sized star use all the hydrogen as a fuel and start to use helium, it becomes into a red giant. At this point, the stars change of color and size. The size increase, the color becomes red. That's where it becomes red giant. From this point, when all the helium is over, the stars collapse and then it becomes into what is called a white dwarf. Okay, so this happens when a normal size, a regular size star, which is between 1 solar mass and 10 solar mass. When it's above 10 solar mass, it can happen two different things. One, these are the blue, big blue stars. It becomes one into, it collapses into a supernova, and then can happen. It can be to a neutron star, or if it's really massive, it can become into a black hole. It all depends on the size of. It all depends on the mass of the star. To make a reference, how heavy are these stars, this remnant of stars? 1 spoon of a white dwarf, it's equals to the weight of the 2 heavy trucks. And 1 spoon, the same spoon of a neutron star, it can be like much heavy than an aircraft carrier. And 1 spoon of a black hole, the same spoon, the same size of this element, a black hole, it cannot be related because there is no such experiment to make about this size. So this is the evolution this is the stellar evolution. We're going to say thank you for listening and good night.